Do you feel the vibes?
Right, so in all of the other functions, we can use transformations, right? And when something moves vertically, it's a vertical shift, and then horizontally, it's a horizontal shift. However, when we talk about trig functions, sinusoidal functions, that horizontal shift is also called a phase shift. Okay, all right. So, the phase shift is basically, the difference between the horizontal position of the original parent function and the function that you're dealing with. So we're going to use a similar process. We need to find the new start and end point, right? Just like we did before. And then we're going to use midpoints to find, the other 4 or 3 critical points. So you always need to have 5 total critical points. Now, so before, when we talked about our parent function, right, or the general form of the function, so you remember there were, right, A, B, C, D, right, the constants A, B, C, D, and each one of them was responsible for one thing. So what was A responsible for? Amplitude. And then B, right, that gives you the period, because 2 pi over B is the period. D, we said, was vertical shift. Now, C and B together, right, give us the phase shift. Okay, so there is like a shortcut for phase shift, but really what I want you to do is to always solve for the phase shift. So take a look at this one here. We have sine of x minus pi over 4. What is the amplitude of this one? 1. And what is the period of this one? 2 pi, because the coefficient of x is 1, right? It's 1x, so b is 1, so the period is 2 pi. Okay, to find the phase shift, you take this, okay, and you set it equal to 0, and then you solve it. So add pi over 4 to both sides. X equals pi over 4 is the phase shift. All right, so if it's x equals pi over 4, that means it starts like it's moved to the right pi over 4 units. Okay, so now it's no longer going to start at 0. So let's find where the new starting and the new ending points are. All right, so let's see. So again, we're going to go from 0 to 2 pi. Inside, we're going to put x minus pi over 4. All right, so now I add pi over 4. So I have 0, x, and this is going to be how much? 9 pi over 4, correct? I'm sorry, pi over 4. So pi over 4 to 9 pi over 4. Okay, so now I have a new starting and ending position. So here the x-axis, the y-axis is that x equals 0. So I go over a little bit. So I have pi over 4. From the pi over 4, I go 1, 2, 3, 4, 9 pi over 4. Okay, now I need to find the midpoints. Finding the midpoints is the same exact way, but now there's a little bit more math. So here for this red one, this is the halfway point between pi over 4 and 9 pi over 4. So look, pi over 4 and 9 pi over 4, that's 10 pi over 4 divided by 2, 5 pi over 4. So that's 5 pi over 4. Okay? Some people can just look at this and they can figure it out. Fine, great, we applaud you. Some people need to write it down. Perfect, right? So now, we're going to find the midpoint between 1 pi and 5 pi over 4. So that sounds like it might be, how much? 3 pi over 4. And then this next one, 7 pi over 4. Okay? All right, so we're graphing a sine, correct? Sine starts on the axis And is there a reflection? No. So we start on, okay, so let's do the y-axis as well. Okay, on the axis, then I go up 1, 0, down 1, 0, and there we go. Okay? So look at this. It's just a similar wave to all the other ones that we just did, but now it's been shifted to the right, pi over 4 units. Okay? Now, let's look at one other thing. Take a look at the very beginning and the very end of this, right? What's the distance from the beginning to the end? So basically that's 9 pi over 4 minus pi over 4, right? That distance. How much is that? 2 pi. And what was the period? 2 pi. So those always have to be the same. Do you see that? Do you see where they all fit in? Okay? Okay. All right, so let's take a look at this one. Okay, so for phase shift, you say 3x plus pi equal to 0. 3x equals negative pi. X equals negative pi over 3. Great, so this has moved to the left pi over 3 units. Okay, so let's go from 0 to 2 pi again. Always from 0 to 2 pi, no matter what. You always have to go with the default period of the parent function. So here, 3x plus pi, right? Subtract pi, so we get negative pi to pi. Okay, now divide by 3, so we get negative pi over 3, pi over 3. Okay, right. So now my starting point is going to be to the left of the y-axis, and my ending point is going to be to the right. But do you see how they're symmetric, right? So where would the y-axis fall? Exactly dead center, correct? So we go negative pi over 3, but now we need 5 points, right? So 1, the y-axis is 2, 3, 4, so pi over 3. Okay, so you got to make it symmetric. So this is 0. And then what's the point between the 0 and pi over 3? How much is that? Pi over 6. Halfway from 0 and pi over 3. That's pi over 6. And then on this side, negative pi over 6. Okay? All right. So here we go. So use that symmetry. So now this is a cosine. Again, you have to label 1 and negative 1. Okay. So negative pi over 3, right? It starts away. Cosine starts away, so we're here. Then we go to 0, negative 1, 0, positive 1, and here we go. There's that cosine we're talking about. Okay? Yep.
What's the period for this one?
Okay, that's a good question. What's the period for this one? No. What's B? Okay, so B is 3. So the period is 2 pi over 3. So now let's take a look here from the beginning to the end, right? Pi over 3 minus negative pi over 3 is 2 pi over 3, which is exactly the same thing as the period. Those have to match every single time. Okay? So whatever the period is, like the period for this one is 2 pi over 3. It might not show up here. 2 pi over 3 might not show up here. But that's the distance.
How do we know
Okay?
the period?
Huh?
How do you know the period?
Because it's 2 pi over b. B is the coefficient of the x.
2 pi over whatever it is.
B is the coefficient of the x. All right. Okay, so moving along, we did this page, so we're here. Okay, let's put it all together. This is like, the mother load of them all, right? This contains everything. Okay, so what is the amplitude here? 2. Just 2. What is the period? 2 pi. Okay, so for the phase shift, we're going to do x plus pi equal to 0. So x equals negative pi. And there is a vertical shift upwards 1. Okay, fabulous. So let's see what our graphing region is going to be. We're going to go from 0 to 2 pi. So this is x plus pi, right? Subtract pi, we get negative pi, x to pi. Okay, good. So negative pi to pi. So here we have negative pi, positive pi over 2 and negative pi over 2. Okay? If you want full credit, you have to label all of these and even put the 0 there. Okay? So 1, 2, 3, 4, 5 every single time. Now, let's label the y-axis as well. We got a 1, 2, 3. I'm going to go up to 4, negative 1, negative 2. If you really want to draw this to scale, okay, how many radian is pi? It's 3.14, right? Mm-hmm. So pi over 2 is like 1.57. So like this distance here is technically 1.57 and this distance is 1. So this is technically not to scale. If you really wanted to draw that to scale, you would fix that as well. Okay, so here we go. There is a vertical shift up 1 unit. So here's the new horizontal axis. Okay? Now, what are we graphing? Sine or cosine? Sine. Is there a reflection? There is a reflection. So sine starts on the axis regardless. Now there is a reflection. So I have to go down. But how much do I need to go down? 2 units. 1, 2. Then back to the axis. Then up 2. Then back to the axis. And that is my curve. You see that? So we have a reflection. We have a phase shift. We have a vertical shift. Okay? Isn't that cool? Right? Okay. So cool. Let's do this next one. They will get prettier. They will get better.
It's hard with no graph paper. It's really hard with no graph paper.
Okay, let's do this one. What's the amplitude? What's the amplitude? 2. What's the period? 4 pi. Okay, phase shift. Half x minus pi equal to 0. Half x equals pi. So what's x? 2 pi. That's the phase shift. Okay, the vertical shift, down 1. Okay, so here we go. So we're going to go from 0 to 2 pi again. Half x minus pi. Okay, so we're going to add pi to all sides. So we go from pi. No. It's always 2 pi. It's always 2 pi and then it will fix itself. So you always go for the default. So now we're going to go from 2 pi to 6 pi. Okay. So 2 pi to 6 pi. So here we go. 2 pi. 1, 2, 3, 4 to 6 pi. So the middle, right, this is just 3 pi, 4 pi, 5 pi. Okay, from beginning to end, how much distance is there? From beginning to end, how much distance? 4 pi. What's the period? 4 pi. That's where it comes in. Okay? All right. So there is a vertical shift down 1. So let's label the 1, 2, 3. I don't want to go up too much here. Okay. So down 1. Oh, crazy. Okay. So 2 pi. That's where we're starting. So this is cosine. Do I start on or away? Up or down? Up. So at here, 2 units up right there. Then I go to the x-axis, oh sorry, the horizontal axis. Because it's a cosine, you start away. Because for cosine, you have to start away from the x-axis, from the horizontal axis. No, not. Okay. Right? So.
Is that bottom point at -3 or -3?
-3. Okay? All right, questions? Okay, now, okay, we can all do this. But if I give you this, just the graph, can you come up with the equation? Well, let's see. Here is a graph. Can we come up with the equation? Well, of course we can. But what we need first is to find A, B, C, D. And we need to figure out, is it a sine or a cosine? That's it. Okay? So to do that, here's what you do first. First thing you want to do is you want to split the graph, I guess, like vertically, right? Down the middle, like this. So just split it down the center like this. Okay? This tells you two things. This helps you find two things. First, the amplitude. The amplitude will always be from that center line up to the maximum or from that center line down to the minimum. And those two should be the same number, otherwise you haven't split it in the correct place, right? So in this case, it's 1, 2, 3, 4 units. So I know that A is equal to 4. Now, another thing that's easy to find when you do this is D. Because the horizontal axis tells you if there is a vertical shift, you can find D. Is there a vertical shift here? Yes, down 2, so D is -2. Now, phase shift is a little tricky because sine and cosine are such that if there's a phase shift of half a pi, sine becomes cosine. So it could be a little tricky. So we're going to agree that the ones I give you are never going to have a phase shift. Okay, so I'm not going to give you phase shift ones. So you're always just going to judge from the y-axis. All right, so C is always going to be 0. So looking at the y-axis here, right? Looking at the y-axis here, this is where the cycle starts. What you want to do is you want to draw one cycle of this. So just trace out one cycle. Now, does that look like a sine or a cosine? Sine. Okay, let's figure out what the period is. It starts and ends, one cycle goes through a length of how many pi? 4 pi. So the period is equal to 4 pi. But remember, the period is 2 pi over b. That's equal to 4 pi. Right? Knowing the period doesn't help you in the equation. In the equation, you need b, the value of b. So now the pi's go away, and then 2 is equal to 4b, so b is equal to 1/2. Okay, next. We need to write an equation. An equation has to have two variables, right? So we have y equals 4 sine half x minus 2. You see that? Okay. So your C is always going to be 0. And then that's it. Isn't that cool? Okay. So here we go. And I can say the most complicated part of this is students just spend time figuring out these 5 points because they do like midpoint, midpoint, midpoint. Once you do that, really, like, everything else is easier, okay? All right, so let's go with homework.
Press start. Bye.